study about the current electricity, and here the derivation of the Ohm's law by the drift velocity. In previous derivations we have learned about the Ohm's law. So here a conductor of length L, cross section area A, and when a current flow I, then what is the relation between N, A, E, V, D? This relation we have also proved in previous video, that is the relation between current and drift velocity. When the current is divided by A, then this will be N, E, V, D, drift velocity. And what is the drift velocity? We have formula. Drift velocity is also E tau upon m into E in previous video. When you put the value of drift velocity, this formula we have just direct used, and we have derived this formula in previous video, fully described. So here we direct use this formula, the relation between current and drift velocity, that is the N, A, E, V, D. N is the number of electron per unit volume, A is the cross section area, E is the charge of electron, that is the flow in this opposite to the current direction, that is the E. And here if the electric field develop between this conductor, and what is the VD? VD is the drift velocity. What is the drift velocity? Drift velocity is the average velocity when electric field is developed on a conductor. So when you divide it by this cross section area and EVD, and what is the VD? VD is E tau upon m into E. E is the electric field applied on the conductor when we flow the current. So put the value of Vd from equation 3 to 1, I equal to I upon A equal to N E square tau upon m into E. This is the equation 4. Put the value of Vd in terms of this formula, and E is the charge of electron. What is the tau? Tau is the average collision time, mass of electron. E is the electric field. And what is the J? J is the current density, that will be I upon A. When you put the formula in terms of J, then J equal to N E square tau upon m into E. This is equation 4. And this is the constant quantity, and this constant quantity will be equal to N E square tau upon m. This is called by the conductivity. Just we have in previous chapter what is the conductivity, N E square tau m, and so J equal to sigma into E, that is the equation 7. So there this value is constant when the number of electron per unit volume, charge of electron, temperature is constant, so the average time will be constant, mass is constant, then the conductivity of the conductor is constant, then J equal to sigma E. So this is called, equation is also called by the microscopical form of the Ohm's law. In various board examination, we can ask about the derive the microscopical form. So you have derived the J equal to sigma E, and if the given J and E direct formula J equal to sigma into E you have to prove, then you have to prove. And here we have derivation of Ohm's law. Then when the potential, and use this equation of the microscopical form, then what is the formula of J? J equal to I upon A equal to sigma. And what is the E? E is this equation. What is the electric field? Electric field equal to, if the length is L and potential is V, the relation between electric field, potential and length, then put the value of this E in terms of this equation. So here this equation will be sigma E V upon L, and we have to calculate the Ohm's law. Ohm's law means we have to prove the relation between current and potential. So we have to generate the relation between potential and current. So relation is here potential and current. And what is the sigma? If you can, sigma equal to reciprocal of the resistivity. When put the sigma V upon L I upon A, so you can solve V equal to rho L upon A into I. This is the equation 10. If you cross multiply by rho into L divided by A, that is the V, interchange the V, then V equal to rho L upon A. What is the rho L upon A? We have already in previous video resistance. What is the resistance? Resistance is rho L upon A. When you put the value of rho L upon A, then this value, what will be the V? V equal to R into I, and we can say V is proportional to I. This is the formula of Ohm's law. This equation is called by the microscopical form. So when the derivation is derived the Ohm's law, this is the microscopical form, J equal to sigma E. This is called by the minor or major form also. You can say this is the minor form and this is the major form. So when you derive the Ohm's law by the microscopical form, then put the value of G in terms of V, and here what is the sigma? Sigma is the reciprocal of the resistivity. And what is the relation between resistance and resistivity? Resistance equal to rho L upon A. In previous video we have derived this formula and we have used this formula. So this quantity will be constant, and potential across this conductor is proportional to the resistance. This is the Ohm's law. So here the Ohm's law is derived by the microscopical or minor form or macroscopical. This is the macroscopical or the major form also called, and this is the minor form also called. So this is micro and this is macro. Macro form and this is micro form. So the Ohm's law is derived by the microscopical and macroscopical form. Thank you.